Hey, so in this problem we're going to figure out what the limit is as x approaches 0 from the right of x raised to x raised to x minus x raised to x. Now let's begin by rewriting x raised to x as e raised to x multiplied by the natural logarithm of x. This tells us that we can rewrite this as e raised to x multiplied by the natural logarithm of x. Now this is just this, so we have x raised to x raised to x is equal to e raised to x multiplied by the natural logarithm of x, and this is all multiplied by the natural logarithm of x. So let's go ahead and rewrite this limit right here using what we have here. We have the limit as x approaches 0 from the right of e raised to x times the natural logarithm of x multiplied by the natural logarithm of x minus the limit as x approaches 0 from the right of e raised to x multiplied by the natural logarithm of x. Now all we've done is separate these limits, which we can do according to the limit laws, so this is a perfectly valid expression. Now let's rewrite this with the limit up here. So we have e raised to the limit as x approaches 0 from the right of x multiplied by the natural logarithm of x multiplied by the limit as x approaches 0 from the right of the natural logarithm of x minus e raised to the limit as x approaches 0 from the right of x multiplied by the natural logarithm of x. Now we want to get this into a form where we can apply a L'Hopital rule. Notice that if we have a and b, we can rewrite this as b divided by 1 over a, because we would just multiply by a up here and a up here, those would cancel and we just have a times b. So let's go ahead and do that to this and this. So we have e raised to the limit as x approaches 0 from the right of the natural logarithm of x divided by 1 over x multiplied by the limit as x approaches 0 from the right of the natural logarithm of x minus e raised to the limit as x approaches 0 from the right of the natural logarithm of x divided by 1 over x. We can evaluate this limit here just by looking at the graph of the natural logarithm of x. It's something like this. Notice that as x approaches 0 from the right, this tends to negative infinity. So this here is equal to negative infinity, and anything multiplied by negative infinity is just negative infinity. So for this part here, we just have e raised to negative infinity. Now we have a limit of the form infinity over infinity, and these two functions are both differentiable, so we can go ahead and apply a L'Hopital rule. So we have e raised to the limit as x approaches 0 from the right of 1 over x divided by minus 1 over x squared. And this just simplifies to e raised to the limit as x approaches 0 from the right of minus x. And this is just equal to e raised to 0, which is just 1. So we have e raised to negative infinity minus 1. We can rewrite this as 1 over e raised to infinity minus 1. This is just equal to 0. So our final answer is minus 1. Thank you very much for watching. I hope you enjoyed the video. Make sure to like and subscribe for more content like this. I hope you have a great day.